Hello everyone, welcome to Learn Overflow. In this video, we will discuss about another LeetCode problem that is the matchsticks to square. This is a medium level problem, and we'll see what this question is asking us to do and how we can think of finding a solution like for this type of questions. So we'll look into the exact question, but before moving on, if you haven't subscribed to this channel, make sure to subscribe to this channel for regular LeetCode videos like this. So the question says, you were given an integer array mastic. So this is the mastic integer array given to us, and where mastics of I, like each of the elements in the mastics array, is the length of ith mastics. Like it says, like each of the elements in this array is the length of ith mastics. Okay. Now you want to use all the mastics, so you need to use all the mastics. You cannot waste any to make one square. Okay, so you need to build a square out of it using all the mastics. Okay. Also, it mentions that you shouldn't break any mastics. Like you shouldn't break any mastics. Okay, and further you can link them up like. And each matrix must be used exactly once. So what it exactly means? So if there's a matrix of say length 4 over here, okay, there's a mastic of length 4. You cannot do something like you break it in half, like now mastics of length 3 and a mastic of length 1. You cannot do that, or a mastic of 2 each. You cannot break them in any order, but you need to use the whole mastics in a fashion. Alternatively, what you can do, you can link them up. That is, you have a mastic of length 4, so you can have a mastic of length 4 and a mastic, some other mastics, say mastic of length 1, and you can link them up to make a bigger one like a 5 length. Okay, so you can link them up, you cannot break them. Okay, further it says you each mastix must be used exactly once, so you cannot use one mastix multiple times. Obviously, if you are making up a square, you cannot do one mastix multiple times, right? So ultimately what it asks us to return, the ask is return true if you can make a square, or false otherwise. So you need to check like if you can make a square out of it. Okay, square in the sense, what does it exactly mean? Look here, if there are basic length of 1, 1, 2, 2, and 2, then if we need to make up a square, we are sure that the square has all of its length is equal, right? So the first thing we should need to check, like what's the sum over here? The sum is 1 plus 1 plus 2 plus 2 plus 2. So that says 8. 8 being its length. So 8 being its length, if we just check for the first thing, that 8 divided by 4 is our 2, right? So if the modulo of this 8 mod 4 is 0 or not, we can check to find that whether we can actually do it or not. Like the first check can be like this. Okay, now see, if our length was something like sum was something like 9, then how what would have been happened? So 9 by 4 would have resulted in 2.25, right? So we cannot break any mastic. So how can we go ahead with the 2.25 value, right? So that's not possible. So we cannot divide with the first check. We can go ahead with just finding the sum and realizing whether we can actually do it or not, like whether is it even possible or not. That's the before even moving into a solution or moving into the stuff, we like what are the difference of what we need to do, we can actually realize that if the sum is divisible by 4, then we are sure that we can think of finding a solution to that. But if the sum is not divisible by 4, we cannot think of finding a solution to that. So 9 is not the case in our example 1. Let's understand what the case we have over here. Okay, we exactly like what we did exactly, we put the 2 1 1 on one side, but remember this is square, so it doesn't matter whether to put it on the left or to put it on the top bottom right. Okay, like it doesn't matter, but something you need to realize that you need to keep a note of that. The reason being, you need to check whether our particular matrix work in the like if we place two matrices on the right, so other matrix like matrix size shouldn't be equal, so you can place them based on what size they have and where we can put them. So this actually to understand like that, we don't have any challenge with putting any matrix like this 1 plus 1 is put on the right, so this can be put on the left like top or bottom as well. But that is not the way you should think. You should think that if 1 plus 1, like if while putting the matrix, if you are putting 1 unit matrix on the left, the other 1 unit matrix can be put on the top, bottom, can be put on the top, can be put on the right. Exactly. So this can happen for the other 1 unit. So that is the kind of check you need to have over here. Like if we exactly put 1 and 1 on one side, it doesn't matter whether the other square is like this or the other square is like this, or how is the exactly square. Okay, the final answer is actually the same, but we can keep a check while we are going ahead with this. Now, what exactly we are doing over here? We simply place the matrix. Like, let's understand this example. We simply place the matrix and we find the square of length 2. So we can have a target of like this, like 2 being the 8 by 4 is like sum by 4 is a number we got. So our target value of length will be that one only. Okay, so there's a square of length 2 we found, and one side of the square can came 2 sticks with length 1. Okay, so it says that one side of the square is a 2 sticks of length 1. So let's try to understand this further. Okay, what I mean is, so you were given over here like this array. Okay, so I'm just writing it down in a bigger format. Two, two, and then two. Fine. Now, what exactly we need to do? Say you just took up like let's see in this manner that you just took say there are four corners. Okay, so one, two, and then three. Okay, and then this four. So these are the four corners of our square we have over here. Fine. Now, what are we trying to do? We took up this one. Fine. For this one, we now have four positions to place them. We can place them exactly at this position, right? We can place them over here. We can place them over here. We can place them over here. So this was the exact thing I was telling a minute earlier that this initially doesn't matter. Like the fourth step, you may say is all the same step. Yeah. So that's true. All the four steps are exactly the same, but it matters when you are going into the further division. So like for the first one, we actually came across four places to put the first one. Okay, one being the left, one being the right, all right, okay, one being the top, one being the bottom. Fine. So these are the four places we have to put our one. Like first one, can you put in this format? Okay. So say we just went ahead with this left one. For understanding, we went ahead with this left one. Fine. Now let's see what are the other cases, how we can place the other values over here. So once we put our left over here, now we come across the next one. Fine. The next one can be again we have four options for us. Fine. Four options for us. Say we sorry, I just took the top one for this case. So let's change this. This is the left and this is the top. Fine. So this is the top. I'm just going there first. We placed it in the top. Okay. Now we find the left, right, left, right, top, and bottom. Fine. Now, after placing the first one, we say we took the left path for placing the next one. Fine. For the next one, this next one. So we just placed the next one over here. Fine. That's why we placed our next one. Now we we had actually four places to put this. We can put it in the top as well. Left, right, top, and bottom is also available for us. Now we put the next one in the left. Next we went to our two. Fine. After going to a two, we know that it will again have like four options to be placed, right? That's the two we are trying to place. Okay. So first is the left. Can you put two in the left? Okay, can you put two in the left? No, we cannot. So we look at the right. That's the second place we have. We can put two in the left, so we put the two in the right. Okay. We went ahead with this particular format. Now we again got four different paths to go. That is with the second two. Fine. That is with this particular two we got this, and again we got four options. Can you put it in the left? No. Can you put it in the right? No. Now can you put it in the top? No. Now we need to put it in the bottom. That's the two being placed over there. Fine. So now after this we placed it in the bottom, right? So once we placed it in the bottom, we will go ahead with again four steps for this last two we have over here. Fine. For this last two, we have also four options. Can I put in the left? Can I put in the right? Can I put in the top? Can I put in the bottom? No. So we find that all the options are closed for us. Fine. So we cannot place our last element at any of the places without even breaking the stick. Okay, but we shouldn't break the stick, right? So without breaking the stick, we can't place it. So the problem is not here. Problem is going ahead with the other solution with the particular way we chose. So we'll simply go back. Okay, we'll simply go back each of the steps to find out what was the step we had over here. So initially we took the left for this one, but we find that this is not a case. So we'll take the right again. So we'll take right for this one. We'll again end up finding that this is not the case. We'll took the top for this one. Okay, we'll take this path and we'll find four solutions. So we took top for this one, fine. And then we found four solutions, place the two at the say first two at the left, then second two at the right. The next two will find that the left right is not filled, the top is also filled. Then we'll find the bottom is to be filled. So once we find that all of the sticks are being placed and all the sticks are fully placed, then we find okay, it's possible. So we find an ultimate solution to our question, and then we need to return back our answer to this. Fine. So that's the question over here. But think of some other corner cases. Say the length is 8. Fine. The length over here is given as 8. But think of a condition where our stick is something like 3 1, 2, and 2. Can we make a square out of it without breaking? No, we cannot. Like if we sum this up and divide by 4, we know the maximum length of our stick is 2, that is possible. Like 2, and the 2 we find that we cannot place 3 anyway. Fine. So this is the kind of corner cases that may be there in our question. So we need to tackle this kind of things also. So the first thing we need to go ahead with, we need to find the sum and divide it by 4. So we just got a target, say t being what will be our target? Target being 2 will be our answer, like 2 will be target in this case. So once we are finding something greater than our target, we can place that value. So once we cannot place that value, that means we cannot form a square out of it. Okay. But once we can place out the value, that is, if it's less than our target, so we can place the value, and we'll keep going with the all the 4 paths. So we are getting, and we'll keep traversing on this path. So this is more or less a tree like a structure. You are going as with a DFS format. We are going to the depth first and try to finding a solution to that. But then we're realizing if it is not a solution, you'll go back and then try to form the solution in another format. So this is the way you will keep traversing, and ultimately trying to find a solution. Okay. So that's more or less the kind of solution we are looking forward to. And now let's try to run this code, like write this code exactly how we are discussing this, and write this code. So remember, to write exactly this kind of code, you will need some kind of additional memory. Additional memory in the sense you need a additional say additional array to keep the sums. Okay, to keep the sums of the like how many additions we did, and like another array of length 4, where we'll place each of the stick at each of the particular indexes, so that we can place all the sticks. Like we are actually dividing all the sticks in groups of 4. Okay, so it's just dividing the sticks in groups of 4. So let's write this code, and again I will explain how the code is working with what we are thinking over here. Okay. So here is a solution for over here. Okay. So what exactly we are doing over here? We're doing exactly what we say we are doing. We just checked for, say, we just the initial one, we are finding a sum. Fine. Then we are checking, like the first thing was if the mastic is null or mastic the length is 0. So if it's 0, if there's no mastic, then there's no way we can find a solution, right? Then we went ahead with finding the sum of all the mastics, like all the elements in the mastic, length of the elements. And actually find if the sum mod 4 is not 0. That is, if it's we find that it's not equally divisible by 4, like we cannot equally divide it in 4 sides, then there's no way going ahead. We just return a false to that. Fine. Further, what we do, we just sorted our array. Just sorted our array in the sense so that we can have all the bigger elements in the last and all the smaller elements in the front. The reason being, we can place the bigger elements, like all the bigger elements are up first, and then we can place the smaller elements at places where we can actually place them. So it just saves our complexity. If you just see over here, if I just take okay, one second. If you just notice over here, if we have something like this, say we have like a value like 3, 1, okay, and then 4, 4, the 4. Fine. If you have something like this, what you can do, is it good, like if you place 1 somewhere and then find where to place a 4? It's always better if you just go ahead with placing the 4, you go ahead with placing the 4, you go ahead with placing all the 4. That's the bigger values we have. So you place all the bigger values. Now what we are left with, we are actually left with placing 3 and 1. So now we know that like if you look into, we don't have multiple choices to place 3 and 1. So for 3 we can have only one choice to place over here, and for 1 we can have only one choice. In case we cannot place 1, in case there is some value like 2 or something like that, or something some value that we cannot place, so we know that by default we cannot place, and we cannot place it over here. Right. So once you cannot place it over here, that means it's not possible. Fine, there's no point going further. But if we go ahead with placing 1 at a place, fine, and then we go ahead with placing 3. Now 3 can be over here. We can place 3 over here. We can like 3 over here, or we can place 3 over here, fine, or we can place 3 over here. So we are going ahead with multiple choices for us, fine. So the choice becomes a much more. So to reduce that kind of small complexity, we just like to reduce some of the small cases we get. So we just place all the bigger values we have. All the bigger values we have in our array. So let's go ahead and place them, fill all the places, and now whatever is left with us is we will place like a smaller value. We will place in the other corners, so that we can find a better solution, like on a faster value we can go ahead with it. So that's more or less the question is all about. I hope you understand. And next, I will go ahead. I'll tell you. That's what is sorted the value. Okay. Next, we took our matrix. We took a length of the sums array for the length 4, so that we can keep each of the side in our at a place. Next, we got the matrix the length -1, so that we can start with our top rightmost element. So that's the length minus the index we are going ahead with. And then sum by 4. Sum by 4 being the target. We shouldn't put any of the sides being greater than our target, right? So that's our objective over here. Now, if our index is -1, like if we keep on traversing from the right to the left, if we traverse this, and after that, if we reach something like -1, that means we reached our target. So we return true. Okay, fine. We reached our target. Now, what we went at we went at all the 0 to 4 of all the sums array, like all the sides array, and then we went out to check like if a particular value, like the sums array initially is 0, but like all the positions initially is 0, but say we place our index at this position, and we find that if the sum plus our matchsticks index, like whatever the matchsticks index is pointing to, okay, so if that is greater than target, like that is greater than our target value, we shouldn't go ahead, like we should go ahead, we simply continue the value. Or if the sum I or sum I-1 is same, so that means if our sum I-1 is the same value, that is we already placed 4 over here, 4 over here, 4 over here. So sum I and I-1 are same values. Then what's the point of going ahead? Like, right, we already placed those values. So there's no point at position I. So we don't need to go ahead with position I. So go ahead with other positions where it is like there is a difference, right? So that's why we continued this. Like we just continue the loop. With this happens when we just placed all the 4 values. So 4, 4, 4 are already there, and we find that sum I like 4 plus say 3 is greater than target. We continue 4 plus like all the 4 plus 3 is greater than target. So there is we end up having the last side we have. So there, what we did, we simply did sum I plus matchsticks of index. Index is pointing at 3. Fine. Sum I plus matchsticks of index. We just place this value. We decided this was sum, and then we went ahead with our further DFS into what? DFS into index I-1. Just move the index a bit lesser. Fine. Now, what further? If our ultimate return from our DFS is a true, we should return true. Like once we find that we can place it, we should return true. That is, once we reach the index -1, we should return true. Fine. And then after this, if we see that we are not finding a solution to that, what we will do? We will simply subtract this. Like we placed a stick at a place, and then we'll remove that stick from the place, thinking that can we find a different way to that. Fine. So we just went ahead with the solution like this, but ultimately, if we'll simply do this, like place a stick. If we're ultimately gonna find a solution, we'll revert back and take up the stick and like replace the stick with some other. So that's what the idea is all about. So once we place the stick, then we replace the stick, like remove the stick from the place. In between, if we find that is this a solution possible, then we simply go ahead with like returning true to our ultimate answer. But in case it is not, we return that okay, this is not a possible solution, and we cannot go ahead with that. So this is all the idea is all about. So I know I can make an understand how the solution exactly works and how we should keep on finding a solution on the questions like this. Okay. So it's all about the thought process you go into to solve this kind of questions. Fine. So that's all about this video, guys. I hope I can make you understand how to solve this kind of questions. If you have any doubts or anything questions, just put them in the comments below. I will be happy to help you out as well. And moving ahead, if you haven't liked this video, make sure to like the video. It takes a lot of motivation. And also subscribe to the channel for regular LeetCode videos like this. So thank you all for watching this video.